Hello everyone. So this is another SCGTA problem. This problem is from probability, and originally this question was asked in AMC 2025, the American Mathematics Competition. The question tells that a frog hops along the number line according to the following rules. It starts at 0. If it is at 0, then it moves to 1 with probability half, and it disappears with probability half. For n is equal to 1 to 3, if it is at n, then it moves to n plus 1, means moving forward with probability 1 by 4, and moving backward, that is n minus 1, with same probability 1 by 4. And it disappears from this, any of the position n is half. Then what is the probability that the frog reaches 4? And this year, Chaitanya is actually taking all the questions from different examinations in foreign countries. That I'm recording this video on 8th May, and the time is 10:29 p.m. and it had just rained. It's raining outside. Now it's very slow, and the frogs are croaking outside. I can hear their noise clearly. Perhaps you cannot hear. But still, we have a frog on the screen, and let's see how it hops. So the question is clear to you now. So please give an attempt, and then you will jump to the solution. So let's dive in and let's see. This question comes in a very interesting topic that is called the recursion probability. And there are many other names also, but we are not going to it. So let's try to understand what the situation is with this frog. So suppose I have this number line, and there are 5 numbers because it starts from 0. So let's say this is 0, 1, 2, 3, and 4. This is final position. As you know, that is given as a final position, and the frog starts from 0, and it wants to hop from here, then from here, and so on, and it wants to reach at 4. So how do we crack it? That's important. You notice that whenever you move any forward motion, you don't know again the frog will go back, and suppose it is repeating as many times he can, it will never reach actually at 4. So in that way, it is very difficult to find out the probability. So in this situation, we have to do some different kind of approach, and that approach is the approach of recursion. So what we're going to do first, let's see. And by the way, there's one thing is given, that it disappears with probability half. Now suppose I ask you that the frog disappears in the middle. Is there any chance that he will reach at the 4? Of course not. And what is the meaning of disappears? What I think, that suppose there are this stepping stones kept somewhere in the middle of the pool, and it wants to hop, and there's a water in between every 2 stones. So you can see that and then the frog sinks down, so he will actually, it will forget the path or its direction to reach 4, and it will not reach to the 4. So this is the meaning of disappearing of the frog actually. So what I can interpret or I can create. Let's see now. So what is happening over here is that. So I'm defining one thing that we have to be very careful to understand. So suppose I'm writing the P4n means the probability that the frog reaches 4 from the n, means n is the position and it wants to reach 4. So I'm just taking the subscript 4 from n. It means, suppose I say that the probability of reaching 4 from 4. This is the probability of reaching 4 from 4. So suppose someone is already standing at the position 4. So what is the probability that it will reach to the 4. That is 100% because already it is there. So that value is 1. Now what I have to evaluate? Because the frog is starting from the position number 0, I have to evaluate the probability P40. It means, let me write it. So P4 from 0 I have to evaluate. So I'm not going to write the all details. Now you understand that what is the meaning of P40. Let's think in this way. Suppose frog has reached at the position 3 somehow. So from the position number 3, he wants to go to 4 or he wants to go to 2, we don't know. So they're given that if for any position n, suppose it wants to move forward, the probability of going forward is half. And probability of going backward is again, sorry, not half, 1 by 4. And probability of going backward is also 1 by 4. So what I can say that, suppose I want to define this situation, that the P43. So P43 means the probability of reaching 4 from the position number 3. So from the position number 3, there will be 3 chances, means 3 situations or 3 cases we can say, or 3 choices the frog has. The first choice, it can go to the position number 4 with the probability of 1 by 4, and when it reaches there, that it has achieved its goal. So probability of achieving the position 4 being at 4 is 1. So therefore this is 1 by 4 into 1. Now it can go backward and the probability of getting back to 2 from the 3 is going to be 1 by 4. But from there again it has to move in such a way that it reaching to 4 from that position. So that I'm calling the probability of reaching 4 from 2, because you notice that the left hand side we want to evaluate the probability of reaching 4 from 3 in all the cases. So this is the first case when the frog was hopping forward, it has already reached, so there is no such problem there. But here what is happening, when the frog is going backward, the going backward has a probability 1 by 4, but it reached 2 there. So from there again there many such cases will appear. How? Because it can go backward, or it can again forward, again backward, again forward, and so on. So why not we can just create a new kind of iteration that we call it, again from position 2, I can say that what is the probability of reaching 4 back. So that I can abbreviate in this symbol, that is a P42, it means reaching 4 from 2. So this we just write it as, let's say, equation number 1. And remember we have to find out the probability of reaching 4 from 0. So we have to just iterate this process till 0 and then go back to find out. So let's now, the frog is at position number 2. So suppose it wants to go to 4 from 2, again it can be in this way. It can go backward or it can be forward. So we can write 1 by 4 times P4 3 plus P4 1. Here also we can take 4 common, but no problem. Now we are going at the position number 1. So P4 1 is going to be 1 by 4, P4 2 and P4 0. Now from that we can go down P4 0. So from P4 0 it cannot go back, because in this question they have given that it starts at 0 and it moves to 1 with probability 1 by 2 and disappears with probability 1 by 2. By the way, I am not including the probability of disappearing because, okay, let me just include it and then I will explain it. Suppose I have the P4D. What is the meaning of this? That reaching the P4 after disappearing. So reaching P4 after disappearing what? Means that disappearing probability from anywhere is half. So this is going to be half. And when disappear, then what is the chance that it will again reach to 4? That is 0, because it disappears, that there's no chance to reach the 4 because we don't know where it is. So in these all cases, I will have this probability to write that after disappearance from the position number n, because P4D I can add there from this position. Again I can add P4D from this position. Again I can add P4D from this position. In every position we can add this, but every position there is this probability 0. Okay, now I go back to P40 then. So P40, what we write again, because now from P40 means the 0 position, I have means the frog will only move forward because there's no backward movement from 0. So that probability to reach position number 1, but from again position number 1, because this left hand side we are evaluating the probability of reaching 4 from 0, and it at position number 1, it means that from there again I have to make the full probability so that it will meet the left hand side probability. So that I have to write what? P41. Now notice that this is the easiest one, and then we have to find out the probability of P40. So let's call this probability as small p or capital P, whatever you want to say, so that our calculation will be a little bit clean without this kind of subscript and all those symbols. So this is going to be what? P41. I'm going to call it twice of P, and this I will save it. Now what I'm going to do? I'm going to substitute this value there. Now see, this value I'm going to substitute here. And in all this process, we're going to reach this position or this equation, and from there we will evaluate the value of P. So let's go for it rather. So this is going to be what? 2P. So this is 2P is equal to 1 by 4 P42. Let me write P42 as it is, and plus P40. But notice P40 again I can write P, small p. So this will going to be 8P is equal to P42 plus P. So what I got, this step is 7P is equal to P42. It means somebody asking that what is the probability of getting that frog to position number 4 from 2, that is equal to 7P. It means if somehow we get the P, we can also find the probability of getting to the position number 4 from any of the position n. So this we got. Again we will substitute this P42 there, where we put it in this equation. Now this equation I've already used, so I will going to put there. So P42 is 7P. So let's use it. Let me mark it, otherwise it will be difficult to understand. I'm substituting this thing there. So this is going to be 7P, and there is going to be 1/4 of P43. P43 I don't know, and P41 I know. P41 is 2P. So let's substitute this 2P there. So that is 2P, and let's calculate it. So this is going to be 28 minus 2. 28 minus 2 is 26P, and that is P43. And now we know the process. This is going to be P43 now. Again in this last equation, in this equation I'm going to substitute it there. So this is going to be, let me write it here, that is 26P is equal to 1/4 again 1 plus and P42. But notice P42 is 7P, so we substitute it there. So 26P is equal to 26 into 4 I can write, and this is going to be 1 plus 7P. So 26 into 4 is going to be 104 minus 7P is equal to 1. So that is going to be 97P is equal to 1. Therefore we got P is equal to 1 by 97. Now once we get the P, whatever position from the frog is hopping to the position number, to reach the position number 4, we can find that probability. So in this way we can do this problem of this frog hopping. By the way, it is also called gambler's ruin problem. But I don't want to scare you with this kind of names and all these things. We simply use our intuition how the iteration works and try to solve it. So I think that's all for today. See you in the next video with some other interesting question. And one more thing that I had decided to create a video on recurrence probability, but I'm not getting time. But still, I think that this problem will work to make a little bit concept clear about this thing. So that's all for today. See you in the next video with some other interesting problem. Till then, stay math active.